Students, so now the problem number 11 is again on the concept of language in automata theory. Tom, theory of automata, I call it as a Tom, theory of automata. Now the situation is changed now. So again, it says the language is S star, it is the language, and where the alphabet is S, that is on A comma B. Now the question says, how many words does this language have of length 4? Again, we have to find out the words of length 4. Okay, how many words of length of 4 would be there, and then how many words of length 5 would be there. Now this scenario is a bit change from the scenario where S was equals to A comma B. Now in this situation, A comma B is the language of single characters only. This is nothing but it is a language of single characters. In this type of situations, the length would take only the single position. For example, if I'm forming the words of from this language, for example, the word W is equals to A B would be of length W equals to 2, because this string is made up of 2 positions. So these whenever we are finding out the length in any string or in any word, we would consider the positions. So this is the position and this is another position. So in this situation, position length is termed as the position the number of symbols from the language contains. Now the solution of this problem can be in a 2 directions. Once, if we are considering this as a character, then there would be the 2 characters, and the length, for example, if the string formed from this can be A concatenated with B. In this situation, this A is a character. This A is considered as a character, and this is another the character. So here there are the 3 characters, but there are 2 strings. We are going to form the word. So now if we are considering A as a character, then length of W would be equals to 3. But if we are considering AA as a string, as from our alphabet, AA is only a single symbol. It is considered as a single symbol. Then the length of this would be equals to 2. Means the length of this would be 2 if we are considering the positions. Whenever we are forming the what we can say, the language from the string, so we mostly consider the positions the characters or the symbols are taking whenever we are talking about the general free languages or general theory of automata. So we would consider this scenario over here, not that other scenario. The question says, if the language is L and that L language is S star, means Kleene Star, and the alphabet S is of 2 symbols, of 2 what we can say symbols of the alphabet. The alphabet 1, the symbol 1 is AA, and double A. This is taking the 1 position only, although these are 2 characters, but position is 1 only. So B is another character, but its position is considered as a 1. The question says, how many words does this language have of length 4? So of length 4 means we have to find out the words of length 4, means where the length of this string must goes to 4. In this scenario, if I'm making a word of AA concatenated with B, as Kleene Star is nothing but it's the concatenation, closure under concatenation. It is the concatenation of S concatenated with S, we can say like this. So A dot B or double A, this dot B means concatenated with B. it is considered as length 2, and I'm concatenating another b, and then concatenating another b, so this would be the length 4. This double a is of position, this is considered as a single position, and its length would be 1, its length would be 1, its length would be 1, its length would be 1. So the whole length of this string would be 4. So if I make this like this, a dot a dot a dot a dot a, now if I'm counting the length on the characters, then its length would be 4. But if I'm counting the length as on the symbols, on the position, then its length would be 4. So in this case, the whole the way how many words would be formed of length 4, this would take the same scenario as a general procedure. For example, from a comma b, the words of length 1 would be a, it's of length 1, and b of length 1. So if the symbols are 2 and we are asked of length, we are length if this here the length is 1, so the number of words formed with length 1 would be equals to 2 power n, the same general formula. So it would be equals to 2 power 1, as the characters are, the length is 1, so it would be equals to 2. So number of words formed with length 1 are 2. If we consider the length 2, then a concatenated with b, the length would be its length would be 2. So the number of words would be 2 power n, and the length is 2, so 2 power 2 would be equals to 4. Again, the 4 words would be formed from length 2. The question is asking how many words of length 4 can be formed and how many words of length 5 can be formed. So the number of words with length 5, where length is 4, would be equals to 2 power 4, and that would be equals to 2 times 2 times 2 times 2, that would be equals to 2 2s are 4, 4 2s are 8, 8 2s are 16, so 16 words. And with length 5, the number of words would be equals to 2 power 5, that is equals to 2 times 2 times 2 times 2 times 2, and that would be nothing but it would be equals to 2 times the 2s are 4, 4 2s are 8, 8 times 2s are 16, 16 times 2s are 32. So with length 5, the number of words can be formed 32. In the scenario where double a is taking only the single position. So this is the solution of the problem number 11, that was asking about the length of the words or the strings of the length 4 and 5. That's it.